So here is what we are working on in Genova. We are working with the Snailaid, which is a no-profit association, and in collaboration with the University of Genova. The association brings together engineers with different backgrounds, and we aim to design the new technologies embedding people's creativity and local resources. We work in different fields. One of these is humanitarian demining. So the philosophy we use is called the snail design system and merges together three concepts: using local resources, using participatory design, that is a process generally used in agriculture in which end users are involved in the design, in the decision making process. And also we want to develop appropriate technologies, which are defined as technologies specifically conceived taking in mind the environment in which they will work. A good example of this is a one laptop per child project developed by MIT. So this is the design methodology we use. It's iterative, and we ask end users' opinion, and we involve their opinions at several stages. We can use also online collaborative tools and more traditional participatory tools involving face-to-face communication when this is possible. This is the PAT machine. It's the first project we developed. These are the partners, and this is the website where you can find more information. It's a machine specifically targeting an environment characterized by soft ground, light vegetation, and small blast mines. And this is what is generally approached with the rake system. And the machine is designed around a power tiller, which is very cheap, versatile, agricultural machine available everywhere in the world, especially in Southeast Asia, where it is also used for transport. So the machine has a modular structure. It has a tractor unit based on the power tiller, a ground processing tool, and a remote control. These are the requirements we use to design the machine. So the existing prototype consists of a tractor unit prototype available at the University of Genova, a ground processing tool prototype, which is in Jordan because we developed there in a local workshop and we tested it there, and then a control unit, again in Genova. The total cost of the prototypization was less than 5,000 euros. So we have an overlook on the tractor unit. We had to add 2 more wheels in the front to keep the machine stable while being operated remotely. Therefore, we had to design a frame, we had to design new wheels that were able to support tracks, and we also had to add tracks because the machine is going to drive over a land that has already been processed, and the factor, the ground processing tool, is at the front. And we also added 2 external disc brakes to achieve steering through differential skid steering. So for designing wheels, we take into consideration the fact that they had to support the truck as well as to engage the truck and move it forward. So we looked into what is existing in the agricultural sector, and we designed a very similar wheel. And this is the 3D model, the crop-up model, and this is the prototype. So this is the frame. The frame serves a double function of supporting front wheels as well as embedding the track tensioning system, which is simply a screw. And the frame is also very simple because it's composed only by standard steel boxes, one sliding into the other. This is the assembling drawing, and this is an exploded view of the front stub axle, and this is pictures taken during the assembling phase. So this is the 3D CAD model, and this is the prototype. So the ground processing tool, it's shaped like an arrow because the aim was to lift landmines on top of the surface, of soil surface, and leave them beside the machine. So we looked into what exists and is similar, and we found the Pearson Engineering mine plow and the potato digger. So this is the way the machine works, where landmines are laid in patterns. So the machine is used only to locate where the pattern is, and then manual demining can keep on going. To design the ground processing tool, we took in consideration three factors. First, we didn't want weight to transfer from the back to the front. We want to keep a constant depth of work, and we wanted to process the soil in an efficient way by cutting it and sieving it properly. So we came up with this design, and we made a cardboard model, and we tested it in a sand test bed we had in the lab, and we decided to change rake and side angle. In fact, the ground processing tool is very simple, and to keep it simple, we decided to make it formed only by plane shapes. Therefore, the whole form is defined when these two angles are defined. So we developed it in a local workshop in Jordan, and in 4 days of work we had the tool ready. So we could test it in a minefield near to Israel. Unfortunately, we couldn't use real landmines, but we had to use wooden landmines. And as the tractor unit was not available as it was in Italy, we used a normal tractor driven backwards. So the main result is that the angles chosen are okay, the soil translocation occurs well, but we could add a tire when the tool has to work in very soft soil, and also vertical tines on top of blades when soil is to avoid the processed soil to go back into the layer. So the control unit, as we said, is we have two disc brakes, so we have to actuate them, as well as we actuate the differential, the clutch, and the acceleration. And that's it. It's a very simple system. It's pneumatic, and it's adaptable to every kind of power tiller with differential. So this is the logical scheme. By now the air compressor is not on board, but can be easily fit on board and coupled directly with the engine shaft. So this is a project we have submitted for funding to the Rotary Club, and these are the partners. It just aims at integrate all modules in a single machine by reiterating the design cycle we used to develop the PART machine and test it accordingly to standards, international standards, in order to provide a solution that can be really an alternative to very expensive machines available on the market. So the new machine will be based on a new power tiller kindly offered by Grillo, and which is new, and we want to demonstrate how flexible is the design. So this is the work we have to do, and the time we need it's probably 10 months, and the budget required is about 7,000 euros. The second phase of the work will regard the dissemination of results by realizing another prototype in Jordan and testing it in a live area. So the expected output is the realization of a very cheap machine, which will cost around 10,000 euros, using innovative participatory design cycle and based on mature agricultural technologies. This is another project we have submitted to the Ministry of Economic Development, and these are the partners, and we wrote it in collaboration with Andy Smith. It's called Locostra, and it aims at develop a new machine based this time on a 4-wheel mini tractor to develop the remote control and design new blast resistant wheels. For the rest, we want to use as much as possible commercial off-the-shelf components and test the machine. This is the machine on which the tractor on which the machine will be based. It's very small and versatile and produced by an Italian company called PR Trattori. The innovative components we are going to design are an external remote control system allowing to drive the machine through articulated skid steering, then blast resistant wheels, and only if required, we will also design magnetic joints to allow detachment of wheels in case of explosion. And then we want also to develop a light armoring to protect the machine against anti-personnel mines up to 200 grams of explosive inside. And the time for this will be 18 months, and the budget 160,000 euros. The expected output is a machine which is slightly more costly than PART or this Armadillo, because we aim at keeping it around 50,000 euros. but more robust and more versatile, using the same philosophy used for PAT and Disarmadillo. Concluding, we think there is a space for research into new, less complex, cheaper technologies for technical survey. If we take these technologies from the agricultural field, then we can enhance local maintenance, sustainability, and also we can improve human development of local communities who participated to the project, apart from achieving a greater impact on mine action.